look at this question that I've got on here. Slay Queen, can I ask you, my sweetie, just to lower your hand for me? There's no way, guys, there is no way I'm leaving today's lesson without hearing Slay Queen's tea. I refuse. We are not going anywhere. I'm going to put you on the spotlight, I swear. Okay, let's look at this first question we've got over here, guys. We're going to look for our common difference. Has anybody found a common difference for me? Hello, Michael. What is our common difference, everyone? It's not going to be +6 because we're not adding this time. We are subtracting. So our common difference is going to be -6. All right, so I'm going to use this formula because I like that formula the best. So Tn is equal to my first term, which is 17. So 17 plus, open brackets, n minus 1 multiplied by -6. Okay, and if I put this in, Tn is going to equal to 17, and then I'm going to distribute my -6 in, and I'm going to get -6n plus 6. Therefore, Tn is equal to -6n plus 23. And I did say, I see somebody say that C is equal to 23. Well done, Mfundo. That is 100% the correct answer that we were looking for. You guys are super duper smart, which I love. And yes, Lulu, they are on YouTube. It works. Okay, Jessica, we're going to try again in just a little bit, but welcome to Watobe, everybody. I am going to ask Jessica to put her hand up because somebody's going to have to do the classroom rules. Unless there's somebody who would like to do the classroom rules as well, I don't think we should gatekeep them. Okay, how are you doing, Jessica? Let me see if I can hear your voice.
Fine, and you, ma'am?
Beautiful, yes. Yes, beautiful, I can hear you. How are you?
Fine, and you, ma'am?
Beautiful, what's up?
Just busy. Tomorrow I'm writing exams again. It's terrible. They don't give breaks and it's hot and you can't learn in this heat, ma'am. Oh my gosh, it's hot.
I don't know where you are, where it's so hot. It's not hot yet where I am, but I'm sorry. I can just imagine the heat must suck. Girl, did you just write a test? Did you write the test the other day? Why are you already writing exams?
I'm writing again. I don't know. I'm in Impact, so it's a very hard school. We just started with the term and they making already, I'm homeschooling, so it's just.
Oh, girl, no, I'm sorry. No, that's not fair.
Can I do the class rules today?
Would you like to do the class rules?
Please, ma'am. I missed it. I love doing the class rules.
Okay. This is what we're going to do, Jessica. I'm going to let you do the classroom rules today, but Amogelang also would like to do the classroom rules, and Slay Queen would like to do the classroom rules. So I think we're going to give them a chance next week. What do you think? Yes?
Yes.
Beautiful. I'm very sorry, Amogelang and Slay Queen. That's our chance. Okay, okay. Let's talk about geometric patterns today. All right. And geometric patterns are going to go a little bit faster. You'll see, guys. You guys are already going to be like, ma'am, chips. Easy things. All right. So instead of a common difference, like we would in an arithmetic pattern, who knows what kind of common what will we find? A common what when we're looking at geometric patterns? What would we get? A common, not a common shape. It's not going to be difference this time. Correct, Swella, well done. It's going to be called a common ratio. And we're going to write it as such. It's going to be a common ratio. Remember when we did arithmetic sequences, we had a common difference because we were minusing difference. When we talk about geometric patterns, we are looking at a common ratio. And we're actually going to write it as we would a ratio, like that. Our common ratio is one number over the other. We know that ratios can either be written like this, or they can be written one number over the other. And that's what we're looking for. We're going to be looking for the constant or the common ratio from one term to the next. Now, when we talk about geometric patterns, nice and easy, we don't get to pick from one formula or the other. We have exactly one formula. We've got Tn is equal to A times, that little dot over there is multiply. We should all be familiar with that. multiplied by our common ratio to the power of n minus 1. Okay, Keegan says, can you say T2 minus? Not minus, not at all. If you are minusing, that is an arithmetic sequence and not a geometric one. Geometric, we must divide. Okay, we must divide. All right, Keegan, make sure. All right. Okay, let's look at our first example. Let's go through this first example. Here's the example that I have for you guys over here. First thing we're going to do, it's okay, my dude, it's fine. All right, no worries, Alex, welcome. All right, let's start over here. We know that we're going to have to find a common ratio. The way we're going to find the common ratio is we're going to take term 3 divided by term 2, and that must give us the same ratio as term 1, or term 2 divided by term 1. Term 3 is 24. So I'm going to go 24 over term 2, which is 12. And that is also going to equal to 12 term 2 over term 1, which is 6. And my answer for both of these, 24 divided by 12 is 2, and 12 divided by 6 is also 2. Well done, guys. So our common ratio is equal to 2. No worries, Kamogelo, I'm going to do this. I'm going to do this. Is that fine? Can you see everything? That's everything that you need to know. All right, beautiful. Okay, and then all we're going to do, guys, is we're going to take our common ratio, and remember A stands for the first term, so T1, and we're going to substitute this into the formula. Okay, so Tn is going to equal to A, which is 6, our first term, which is 6 multiplied by 2 to the power of n minus 1. Now, here's my next question. Can I then take 6 and multiply it with 2 and give that my formula as 12 to the power of n minus 1? Can I do that? Yes or no? Okay, I got 1 yes, I got 1 no, I got 2 yeses. Okay, the correct answer is no. All right, and the reason for that is, let's say, for instance, our n was 3. If I had 6 times 2 to the power of 3 minus 1, I'm going to end up with 6 times 2 to the power of 2. 6 times 2 to the power of 2 is equal to 24. That's the answer I should get. Now, if I make this 12, I'm going to end up with 12 to the power of 3 minus 1, which is the same as 12 squared. That gives me 144. I can't do that. I can't do that because this 2 to the power of n minus 1 is its own thing. I can't take the 6 and the 2 and multiply them together. Give me a thumbs up if you understand what ma'am is saying. We cannot multiply the 2 of them together. That is not 2. It's 2 to the power of something. Okay, let me see. Swella, you're allowed to write it that way. That's perfectly fine. You can write it like that. Anotida, n is going to be the term number, and I'm going to explain. Let me explain. All right. Let me explain. I'm going to use this exact same equation that we just got here. I'm going to rewrite it very quickly because all of this is a mess and we shouldn't be considering that. All right. So remember what we said, guys, in that first thing that we did, right? In the first sequences and series that we did, we said that this is term 1. This is term 2. This is term 3. This is term 4. And this is term 5. And there is no other formula, Siamtanda. In grade 10, this is the only formula you can get. And if you use any other formula, you're probably going to have to derive it, which is a little bit more difficult. Now, our Tn is going to be 6 times 2 to the power of n minus 1. That tells me that my T1, my first term, should be 6. What this means, guys, is that if I put 1, if I replace all the n's with the number 1, the answer I should get out is 6, Right. So now if I ask you guys, what is T4? What answer are we expecting to get out if we replace n over here with 4? What answer are we expecting to get out? Correct, Jessica, beautiful. Yes, that's it, Nomfundo. Good, Amy, good. We know that we should get 48 out. Let's actually test this theory. Okay, T4 is going to equal to 6 multiplied by 2 to the power of 4 minus 1. That's going to be 6 to the power of, or 6 times 2 to the power of 3. I know that 6, okay, 2 to the power of 3 is 8. So I technically have 6 times 8, which is indeed 48. And that's the answer we should get. So that n that we're talking about tells us about the position. The number in the first position is 6. The number in the fourth position is 48. That's why we have T4. What is the number in the fourth position? It's 48. What is the number? Let me ask this question. What is the number in the fifth position? What is the number in the fifth position? That's it. Enke, are you with me now? Are we all good? So that means if I then replace n over here with 5, the answer I should get out after I calculate should be 96. Give me a thumbs up if you're understanding what I'm saying. Hi, Siamtanka.
Hello, ma'am.
Hello.
How are you doing, ma'am?
I'm excellent. Thank you. How are you?
I'm good. I just have a quick question about the common ratio. So
Yes.
specifically how to find it, we have to only use the first 3 terms.
Pretty much. You could actually use any of them. We could say that the common ratio is T5 over T4, and that must equal T3 over T2. Okay, as long as it's the one before divided by the one, or the one after divided by the one before. But they must both give you the same answer, Siamtanda, because if they don't both give you the same answer, then you don't have a common ratio.
Okay, thank you, ma'am.
Right.
That's all I wanted to know.
You're very welcome. Good stuff. All right. Okay, cool. Let's put all of this to practice. It's your turn. It's your turn. Let's go with this first question over here. They say, we are given the geometric sequence 2, 3, 4,5, 6,75. Now it says, write down the next term in the pattern. Now we need to check how much they are multiplying by to get from the first to the next one. So let's start by finding the common ratio, because just finding the next sequence, the next number in the sequence, not going to help us as much as we'd like. So let's look for the common ratio first. Now remember, guys, the common ratio is going to be T3 over T2, which should also equal T2 over T1. What's up?
Hi, ma'am. How are you?
Excellent. Thank you, my sweetie. How are you?
Ma'am, I just don't understand the first one that we did. So for the Tn is equals to, for the Tn is equals to 6 times 2 to the power of n minus 1. What's actually the answer for it? Because you showed us the example while we using the T4. That's what I don't understand.
Okay,
actually.
so let me remove this. This is the general formula. Remember, anything, if you have Tn is equal to something, Tn is equal to 6 times 2 to the power of n minus 1. This is called the general formula. Okay, that the general formula means it must work for any number that we put in. Okay, whatever answer for n, number for n that we put in, we must get an answer out. Okay, so now remember, Tn is the actual number and n is the position, right? So
Yes,
this n over here stands for the position. So if I say I want the number in the third position, I'm going to replace n with which number? Third position, n will be equal to?
24.
To 3. N is equal to 3. Do you understand what I mean? we're going to replace n with 3. And then once we finished calculating T3, my answer must be 24 on this side. Are you understanding what I'm saying? So we're taking whatever position we want, and we're replacing that position where n is, and it should give us an answer out.
Okay.
Have you got it?
Oh, yes, I got. Oh, so the 6, it's actually the first position.
Yes, it's the first term. Remember, there's an A here. A stands for the first
The
term. And there's our first term.
Okay. Thank you, ma'am.
You're very welcome, my sweetie. Keep those questions coming. If you guys are also stuck and you're not 100% sure what's going on, let's do that. Ask me as many questions as you need. All right, okay, let's talk about this. This one over here. We're given the geometric sequence 2, 3, 4, 5, 6, 7, 5. So let's find R. Ntokozo, I'm going to take your question in just 1 second, my sweetie. Don't put your hand down. Okay, so to find R, this is T3, this is T2, this is T1, this is T4. So R is going to be 4, 5 over 3, which should also equal 3 over 2. Now, the answer is 3 over 2. We can say that our common ratio is 3 over 2, but because they're using decimals, I'm also going to take 3 over 2 and I'm going to turn it into a decimal. I'm going to write it as 1,5. So our common ratio is 1,5. Now, that means to get from T4 to find the next term, T5, I'm not going to add. It's not an arithmetic sequence. It's not an arithmetic sequence. It's a geometric sequence. So instead of adding, we're going to multiply. We're going to take 6,75 times 1,5. And the answer we get out is 10,125. All right, we've already found our common ratio, which is 1.5. Now I want you guys to use the information you've gotten here to give me TN. Okay, pop your favorite answer, your favorite emoji in the chat once you've got an answer for me while I take Ntokozo's question. Hello, my sweetie, how are you doing?
I'm fine, and you, ma'am?
I'm good, thank you.
Ma'am, it's about the previous question. I don't quite understand it.
Okay, where did I lose you?
I came in while you've started it.
Okay. All right, my sweetie. So have you done geometric sequences before?
I did at school. We did the one we were doing on Monday.
Okay, all right, let's talk about this one. So Tn, this is the general formula. Tn is equal to A multiplied by R to the power of n minus 1. Okay, now remember in the one that we did on Monday, we said to get from the first term to the second term, we need to add the same number over and over. Yes?
Yes.
Okay. Now in the geometric one, instead of adding to get to the next number, we need to multiply. Correct. That's why our n is in the exponent, because when we multiply something again and again and again, it gives us that number to the exponent. You got me?
Yes,
right.
ma'am.
So we're going to take the sequence. Let me rewrite the sequence down here so that people can see. Okay, so we're going to, the sequence is 6, 12, 24, 48, 96, right? This A over here, do we remember what A stands for? What does A stand for?
First one.
Correct, it stands for T1, the first term, right? Stands for the first term. Now, to find the common ratio, do you see what ma'am's written down here? To find that R in the equation, common ratio, we must take T3 divided by T2, and that must also equal T2 divided by
T1.
So we're going to go to this formula. This is T1, this is T2, this is T3, this is T4, this is T5. Are you with me?
Yes, ma'am.
Okay. Now let's substitute. We're going to go, if we want to find the general formula, we're going to say Tn is equal to A. What is my A? What is my first term?
6.
Good. So we're going to write 6 times, what is my common ratio going to be? How did I get from 6 to 12 to 24 to 48?
You're adding
I'm not
6.
adding.
Oh, times
We're not.
by
By
2.
2. Good. We're timesing 2. Because if I add 6, it must be the same everywhere, right? But 6 plus 6 gives us 12, but plus 6 doesn't give us 24. So it's definitely not the arithmetic pattern that we did on Monday. So we must times. So our common ratio is going to be 2 to the power of n minus 1. Okay. Now, Ntokozo, if I said to you that I want the 5th term, I want the 5th term. 5th term, that means my n is going to equal to 5th, n is equal to 5. Okay, n must equal 5 in our formula. So I'm going to go over to this formula over here, and wherever I see an n, I'm going to replace it with the number
5.
5. Good. So let's do that. We're going to go T5 is equal to 6 times 2 to the power of 5 minus 1. I want you to punch this into the calculator for me and tell me what answer you get.
Yes, ma'am.
All right. While Ntokozo runs to get her calculator, let's the rest of us finish up here. Okay, give me an answer when you're ready, Masudi. Okay,
Yes,
all right. Okay, so our Tn is going to equal to A multiplied by R to the power. Have you got an answer for me? Ntokozo, what's the answer?
It's 1,475, comma.
Oh, how?
Oh,
Okay.
you see?
How did we get that? How did we get that? Okay, remember this dot over here doesn't mean comma, it means times. Okay, that means times. Okay, so we must write 6 on our calculator, write 6 times 2 to the power of 5 minus 1.
Oh, it's 96.
It's 96, right? And we can confirm that because there's the number in the 5th position. What is the number in the fifth position? 96. That's exactly the answer we got. Okay.
Yes, ma'am.
Are you happy? Are we understanding where everybody's at?
Oh, yes, ma'am. Thank you.
Beautiful. You're very welcome, my sweetie. Excellent. Excellent. All right. Okay, let's do this one over here. Now we know that our Tn is going to equal to, my first term is 2 multiplied by, now I'm going to take my 1/5 and I'm going to put it in a bracket, 1/5 to the power of n minus 1. And Jessica, I hope, teacher Nels, have you spoken to Jessica about this particular question? Jessica, does this clear up number 3 for you? I hope we're okay with that answer over there. Okay, just let me know if you figured out how we can do this. Beautiful. Okay, now it says find the value of the 10th term. So 10th term tells us that our n is going to equal 10. So we're going to go into our general formula that we've just made over here, and wherever we see an n, we're going to replace it with 10. So we're going to go T10 is equal to 2, open brackets, 1/5, close brackets, to the power of 10 minus 1. And the question says correct to 2 decimal places. So punch that into a calculator. Thank you, Sisipo. I've got my calculator here, but I was so lazy. Thank you. The answer we're looking for is 76,89. Give me a thumbs up if we all got the same answer. Did everybody get the answer 76,89? Yes, beautiful. Now let's work our way backwards. Let's work our way backwards, because in the other question, we didn't really, I mean, in Monday's lesson, we didn't get a chance to work our way backwards. Now, here's what we're going to do, guys. Here's what we're going to do. It says here, determine which term is equal to 10,125. So this is the whole of Tn. When they say which term is 10,125, we're going to replace the whole of Tn. The whole of Tn with 10,125. So here's what we're going to do. I'm going to write 10,125 is equal to my general formula. 2 multiplied by 1,5 to the power of n minus 1. Okay, now I want to solve that thing that says n to the power of n minus 1. So the first thing I'm going to do, correct Mfundo, I'm going to get rid of 2 by dividing by 2 on both sides. Let's start there. Somebody please give me an answer. What is 10,125 divided by 2? Patience? Hama sweetie, what did you get?
I remember I got 5,15. Yeah,
5,5.
115. Something like that.
Okay, check again, my sweetie, check again, because the answer I'm getting is 5,0625.
Oh, guessing we're
Okay.
taking it from here.
Okay, so take 10,125 and divide by 2.
Yeah. Yeah.
Did you get the correct answer?
Yes.
Yes?
So yeah, I did it 5,6.
0625. Yes?
Yes.
Okay, cool. Thank you, Patience. That's the answer I was looking for. Okay. Well done, my sweetie. All right. So now here's our problem. Here's our big problem. When we look at this sum over here, we don't really know how many times 1,5 is going to go into 5,0625. Right. So what we're going to do is we're going to go to our calculator and you're going to type in, you're going to click SD. Okay, click the SD button because what I actually want is I want 5,0625 as a fraction. What fraction does that give us? 5,0625 gives us what fraction? Look on your calculator, there will be a fraction button. Good. It's going to give me 81/16. And that's going to equal to, how else can I write 1,5 as a fraction? 1,5 as a fraction is what? Correct, 3/2. Good, 3/2. So I'm going to then do this. 3/2 to the power of n minus 1 is equal to that. Right, now, this next part is going to be, okay, click that, Anotida. Okay, so this next part is going to be a little bit tricky. Okay, correct, Patience. Right, this next part is going to be a little bit tricky. So what I want is this 81 over here to have a base of 3. Okay, so I need to think of a number that's going to be 3 to the power of something is equal to 81. Who can tell me what that number is? Beautiful, CC Paul, well done. 81 is the same as 3 to the power of 4. So I'm going to take this 81 over here and I'm going to replace it with 3 to the power of 4. Okay, so that's my next move. 3 to the power of 4 over, now, because at this number over here at the bottom, there's a 2, I want to write 16 as 2 to the power of something. How else can I express 16 with a base of 2? 2 to the power of 4, correct, 2 to the power of 4. So 2 to the power of 4 is equal to, now on this side, I've got 3/2 all to the power of n minus 1. Okay, I just want to close this section because we're going to need some space, just a little bit of space. All right, so here's the next thing. Do we note, give me a thumbs up in the chat if you're with me, that 3 to the power of 4 and 2 to the power of 4 both have the power of 4 in common. Yes? Are we all okay with that? 3 to the power 4, 2 to the power 4, both have to the power of 4 in common. So what I'm going to do is, I'm going to take this 3 over 2, and I'm going to write it as a fraction to the power of 4. So I'm going to rewrite it as 3 over 2, all to the power of 4. And that's going to equal to 3 over 2, all to the power of n minus 1. Okay, are we noticing something now? What do we notice? What do we see? Yes, Mawande, good. My bases are the same. My bases are the same. So if my bases are the same, what does that tell me about my exponents? If my bases are equal, that means my exponents are also equal, correct? My bases are, my exponents are also equal. So I can then cancel my bases, and I can then say 4 is equal to n minus 1. Solve for n for me. What is the answer for n? Correct. Ooh. When that negative 1 goes over to the other side, it becomes positive 1. Therefore, n is equal to 5. Ooh, that was hectic. That was super hectic. But beautifully done, guys. No worries, Mfundo. Just remember, I forget also sometimes, and I do stupid things like forgetting to change the sign. I do it too. Okay, all right. I know this one was a bit hectic. Let's look at another example. Okay. It's okay, Mawanda, we kind of sometimes make silly mistakes. Let's look at this next one over here. They say we are given -5, 10, -20, 40. Now it says here, show this is a geometric sequence pattern. And the way you're going to show that this is a geometric pattern is by finding the common ratio. I'm going to remind you guys, the common ratio is T3 over T2, and that's equal to T2 over T1. And everybody else, go ahead and do this question. Refilo, you're going to do this question with me. Unmute for me, my sweetie. Let's talk.
Hello, ma'am.
How are you?
I'm fine, and you, ma'am?
I'm good, thank you. Okay, let's find. Do you know how to find the common ratio? Are we okay with finding the common ratio?
Yes, ma'am.
Okay, let's do it together. I'll show you. This first example that we just did was a little hectic, so let's do it with this one. This one's going to be a little bit easier. Okay, so we're going to take T3 over T. So you're going to tell me what R is equal to. What is T3? What is term 3? Remember, this is term 1, this is term 2, this is term 3, term 4.
20.
What is term 3? Rafile? Hello? Rafile? Oh no, I've lost Rafile.
Can you hear me?
All right, Rafile, can you hear me again, my sweetie? Please unmute.
Ma'am?
Hello? You're muted, my sweetie. Okay, I'm going to try and take this slow. Rafilo, are you there?
Yes, ma'am, I'm there.
What is my T3?
Ma'am, our T3 is 20.
It's not 20.
-20, -20.
Correct, it's -20, good. So we're going to have -20 divided by what?
10.
Good. And that must equal, what must that equal?
10 divided by
Over?
-5. -5.
Good. What answer is that going to give us? What does that tell us about the ratio? Ratio is equal to?
Can I log it into my calculator quickly, ma'am?
You don't even have to do them both. You can just do one of them. You can either do that one or that. They should both give you the same answer. What is the correct?
-2.
-2. Beautiful. Okay, let's put this into a general formula. We know what our general formula is. Tn is equal to A times R to the power of n minus 1. The two things we're going to replace is A and R. Okay, I want you to do that for me. So Tn is going to equal to what?
-5 times
Good, -5 times.
to the power of n minus 1.
Good, -2 to the power of n minus 1. Excellent. Now, Refilo, the next question says, what is the value of the 12th term? This tells me this 12th term means what are we going to replace with 12? Which part? Which part of our formula?
Tn, ma'am.
Not Tn, not
Oh,
Tn.
N.
Which part?
N.
N. Good, just N. Only N is equal to 12. So let's go ahead and do that. Okay, so we're going to go T12 is
N.
equal to, finish up for me.
Is equals to -5 times open bracket -2 to the power of 12 minus 1.
Beautiful. You're going to put that in your calculator for me. Give me an answer.
Okay, ma'am. -5.
Remember that dot means times. That's why I put the brackets there though, so we don't get mixed up. Okay.
Excuse. It's 10,240, ma'am.
Beautifully done. 10,240. Well done. Beautiful, Refile. Now I want you to do this next one with me. Okay. Okay. We're not going to do C today because we've. Okay. Now it says, is 1280 in the pattern? Show your working. Now this number 1280, which part of my equation is that going to be?
I think it's Tn,
The
ma'am.
N? Correct, it's Tn, beautiful, it's Tn. So we're going to go into our formula and we're going to replace the whole of Tn with 1280. So we're going to go 1280 is equal to -5 times -2 to the power of n minus 1. Right, what's our next step?
I think we
What's-
solve for n. We solve for n.
Good, we're going to solve for n. But what's the first thing we must get rid of in order to solve for n?
The brackets between, we must multiply -5 and -2.
No, we can't, because this isn't -2. It's actually -2 to the
Divide by
n.
-5.
The first thing we want to get rid
Divide
of
by
is,
-5.
yes,
Then the
five.
chat, yes.
Good. So we want to divide both sides by -5. Good. So you're going to go into your calculator, 1280 divided by -5. Give me an answer.
Okay, ma'am. 1280 over. It's -256, ma'am.
Beautiful. -256 is equal to, now that part is gone. I've now got -2 to the power of n minus 1. Now I'm going to have a problem because exponents and negative numbers, they don't really work that well together. So how can I get rid of these two negatives? I can just divide both sides by what?
Ma'am?
What can I divide by to get rid of that negative on both sides? Check the chat. Everybody's being very smart, except no, Dinswalo can't divide by -2. What can we divide by?
-1, ma'am.
Correct. I'm going to divide this side by -1. I'm going to divide this side by -1. And then our problem will be gone. The negatives will go away. The negatives will go away. So now my formula reads 256 is equal to 2 to the power of n minus 1. Okay, now I have a problem, Refilwe. I have a base of 2 on this side, and I want 256 to also be 2 to the power of something. What is that something going to be? How can we write that? Now, if you don't know how to do it, here's what you're going to do for me. You're going to go to your calculator, my sweetie, and you're going to click on your calculator, 256 equals. Okay, can you do that for me? Have you got an answer? Refilwe? Phew, okay, Refilwe's gone. I don't know what happened, but the rest of you guys, if you're there, go ahead and do this. I need you guys to click on your calculators, 256, click the equal sign. Then I want you to go to your calculator and click shift, and then look for a button. It's written in yellow above this button. The button looks like this. It looks like this. Okay, that's what it's got, like these three little kapikis with the dot on it. So you're going to click shift and then click that button that actually says fact. It's got the word fact on it. And tell me what your calculator does. What does your calculator do? When you go 256 equals shift fact, it gives you the number that we want with the base that we want. And now I'm going to get 2 to the power of 8 is equal to 2 to the power of n minus 1. Correct, Lulu. It gives you the product of its primes. Excellent. Now that my bases are the same, what does that mean about my exponents? My exponents are also the same. So I can drop them. Right, so that goes. Now I have 8 is equal to n minus 1. Therefore, n is equal to, beautiful, n is equal to 9. Give me a thumbs up if the steps we've just taken make sense. Yes, okay, Keegan, the problem with negative numbers is that sometimes, actually, no, the negative is in the right place. I was thinking we're going to have log issues. We were not going to have log issues. We're not. Only if the exponent was in the, if the negative was in the exponent, then we'd have log issues. Okay, all right. Give me a thumbs up, everybody, if we're okay with the steps that we just took to find the answer. Hi, Riamorata, what's going on?
Hello, ma'am.
Hello, my sweetie.
Hello, ma'am.
Hello.
Ma'am, I wanted to ask, why is our n equals to 9?
Okay, remember, if we remove the bases, we're going to have 8 is equal to n minus 1 left, right? 8 is equal to n minus 1. Can you solve for n for me? What would we do in this case?
We will take the 1 to the 8 and change the sign to positive.
Correct. So that's going to be 8 plus 1. Therefore, n is equal to?
Oh, okay.
9. Okay, are you with me?
Yes, ma'am.
Okay, excellent. Good stuff. All right.